be real, in programming, things are gonna go wrong. It's just a fact. Today, we're diving into Java's super powerful system for dealing with those errors, exception handling. This is the absolute key to turning a fragile app into a rock-solid one.
I mean, really think about that for a second. Errors happen all the time, right? A file you need is missing, the network drops, a user types in garbage data, and what's the usual response? Boom, a total crash. But what if, instead of just, stopping dead in its tracks, your program could catch that error, deal with it, and just keep on running? So here's the game plan. We'll start by looking at why programs crash. Then we'll introduce the try-catch safety net. We're gonna peek under the hood to see how it really works, tackle what to do when you have multiple errors, and this is a big one, cover the common and dangerous mistakes you have to avoid. All of this will lead us to the holy grail, writing truly robust code. Let's get into it. So let's dive right in. What really happens when good code goes bad? Well, without a plan for dealing with errors, even one tiny little mistake can bring your entire program to a screeching halt. Okay, check this out. It looks simple, right? Int result equals 10 divided by 0. But this line of code is a ticking time bomb. We're asking Java to do something that's mathematically impossible, divide by 0. And in the Java world, this creates a very specific kind of error called an arithmetic exception. And the fallout from this? It's bad. If our program prints start and then hits this line, it doesn't just get confused, the whole application just dies. Notice how end never even gets a chance to print. The execution just stops, dead in its tracks. All right, but this is where we get to take back control. Java gives us this incredible tool to see these problems coming and manage them, turning what was a fatal crash into just a manageable little bump in the road. This slide says it all. On the left, you've got that uncontrolled crash we just saw, but on the right, we've intervened. By wrapping that risky code in what's called a try block, we're basically telling Java, hey, try to do this, but be ready for things to go wrong. And that catch block, that's our contingency plan. It's just sitting there waiting to jump in if, and only if, that specific arithmetic exception happens. And just look at the difference this makes. It's a total game changer. The program starts, it hits the error, but instead of crashing, it takes a detour right into our catch block. It prints out a nice, helpful error message, and then, this is the crucial part, it keeps going and prints end. The program now runs all the way to completion. We've handled the error.
So what's actually going on inside the Java virtual machine when all this happens? It's not magic, I promise. It's actually a very clear, very logical process for finding the right plan B.
Okay, so the moment an error pops up, the JVM instantly creates this little package of information called an exception object. Then it looks right where it is in the current method for a catch block that knows how to handle this exact problem. If it doesn't find one, it starts climbing up what's called the call stack. It goes to the method that called this one and checks again. It keeps climbing this ladder until it finds a handler that's a match. As soon as it finds one, it hands over control, and bam, the program is saved. And that little E you see in our catch block, that's our exception object. You can think of it like a detailed incident report. It holds the error message, like /by0, and it also has a full stack trace, which is basically a roadmap showing the exact path the code took to run into trouble. Super useful stuff. All right, so we've got the basics down, but what happens when your code is a bit more complex? What if it could throw more than just one kind of error? Let's level up and look at how to handle multiple different exceptions like a pro. So back in the day, before Java 7, things were kind of clunky. If you wanted to handle different errors in the same way, you had to write a separate catch block for every single one. It led to a lot of copied and pasted code. But since Java 7, we've got this beautiful thing called multi-catch. With just that one little pipe symbol, you can catch a whole bunch of different exception types in one clean, efficient block. So much better, right? Now, there is one super important rule you gotta remember with this. In Java, exceptions have these parent-child relationships. A file not found exception, for example, is just a more specific type of IO exception. You're not allowed to list both in a multi-catch block, because if you catch the parent, the IO exception, you've already covered all of its children by default. The compiler is smart enough to flag this as an error for you. The takeaway is, just handle the more general one. Now, this next part is really, really important. Whether you're handling one error or 10, the real danger isn't the error itself, it's how you handle it. In fact, handling exceptions poorly can be way more dangerous than not handling them at all, especially when it comes to security. This quote just nails it. An empty catch block
What programmers call swallowing an exception is a massive red flag. It basically creates a silent failure. The program doesn't crash, which might seem good, but it could be left in some weird, corrupted state. And that can lead to some truly bizarre bugs, or even, as we're about to see, a major security hole.
Let's make this real. Picture a login method in some application. It starts off by optimistically setting a variable, logged in, to true. Then it tries to check the password. But look at that catch block. It's completely empty. The person who wrote this probably thought, what could go wrong? Well, a lot, it turns out.
So here's how the attacker pulls it off. They don't send a password, they send a null value. When the code tries to work with that, it immediately throws a null point exception. The program's control jumps straight to that empty catch block, which of course does absolutely nothing. It just swallows the error and moves on. And since logged in was never changed back to false, the method finishes and returns true. And just like that, the attacker is in. Scary, right? But check out how incredibly simple the fix is. By just adding one single line, logged in equals false, inside that catch block, the entire vulnerability is closed. Now, if any error happens during that password check, the login is guaranteed to fail. It's a tiny change with a gigantic impact on security. Okay, so let's pull all of this together. As you can see, exception handling is about so much more than just stopping your app from crashing. It's about building software that's predictable, secure, and easy to maintain.
So here are the key practices to live by. First, be specific. Don't use a sledgehammer like the generic exception when you need a scalpel. Second, and I can't say this enough, never leave a catch block empty. Always handle the error. Third, if something fails, do your best to restore your program to a clean, safe state. Fourth, protect your users and your system. Never show raw stack traces in public-facing error messages. And finally, use modern features like multi-catch to keep your code clean, readable, and effective.
And that really brings us to the whole point of this. Learning this stuff isn't just an academic exercise, it's intensely practical. So I want to leave you with this question to think about. Looking at your own projects right now, what's one potential error that you're currently ignoring that you could start handling more robustly today?